Okay, so just like the last one we talked about, your first step should still be the same. You should try direct substitution. So you get 3 times cosine of pi over 2 squared. And what is the cosine at pi over 2? Pi over 2 is here, cosine's the x value. So 0 squared, so it looks like all of the numerator goes to 0. Do direct substitution down here, you get 2 minus 2 times the sine of pi, and the sine of pi is 1. So it looks like we got 0 over 0. You want to start with that, because if you don't get 0 over 0, then you're basically done. It's only when it's 0 over 0 we have to rewrite this stuff. So we've got some very common stuff. Factoring is very likely. So like I look at this bottom and I could factor out a 2. I don't know if I need to, but it doesn't hurt to try. And I know something has to cancel out before direct substitution works. So cosine squareds and a regular sine don't sound alike. So the trick to this question is using our first Pythagorean identity from last semester. Instead of saying cosine squared, we could say 1 minus sine squared. So that gets us to here. Now again, I know the challenge in a lot of these questions is trying to figure out what to do next. And not that that's always going to be easy, but you know something's supposed to cancel out. So it doesn't look, I mean, I don't see any way I'm ever going to get a 2 out of the numerator, so it's probably not the 2 that's going to cancel. It's probably the 1 minus sine x. So this, although not super obvious, this is the difference of 2 squares. You've got 1 being squared on the left, you've got sine being squared on the right. Difference of 2 squares always factors as a positive and a negative. So it goes back to, I know you can all factor the difference of 2 squares, but do you recognize that it's the difference of 2 squares there without being told? And then finally, 1 minus x squared cancels out. Plug into what you have left over. The sine of pi over 2 is 1. There's nothing to plug it into in the top. And you end up with 6 over 2, which reduces to 3. All of that comes out to 3. So that's what I would call an indeterminate form question, because we had 0 over 0. But the main trick was using trig identities, thinking to rewrite cosine squared as 1 minus sine squared. That is just one tool to deal with indeterminate form. Okay, anything more particular about 13 before we move on?